Methodology to minimize the dynamic response of tall buildings under wind load controlled through semi-active magnetorheological dampers. This study focuses on analyzing a tall building with 99.75 meters, described by a 2D frame model of multiple degrees of freedom, under dynamic wind loading and controlled by semi-active MR dampers. Three different configurations were analyzed. C1 is a frame without control system. C2 is C1 frame with fundamental frequency optimized as a function of its mass. C3 is C2 frame controlled through a set of semi-active MR dampers. The drag force of the synoptic wind was determined by a mean component and a fluctuating component, and the MR damper was modeled by the modified bulk 1 rheological model with LKR clipped optimal control strategy, composed of stiffnesses and dampers that results in a damping force. For C3, the dynamic equilibrium equation was solved several times, increasing the amplification factor omega until satisfying the performance criterion as demonstrated by the pseudocode. In this work, three performance criteria were used: maximum acceleration, maximum displacement, and maximum story drift. In terms of displacements, C3 showed a reduction of 71.2% in relation to C1. For the accelerations, it could be seen that C3 showed a decrease of 76.7% in relation to C1. Finally, in terms of story drifts, C3 showed a reduction of 60.3% in relation to C1. It was found that the C3 configuration was the only one able to meet all the established performance criteria. MR dampers proved to be a powerful tool for vibration control.